Good morning, students. Now, today we are going to discuss the last topic of the chapter. And that topic is, students, the linear differential equation, LDE. Now, a differential equation of the type dy by dx plus p into y is equal to q, where p and q are functions of x only, is called a linear differential equation of first order and first degree. Students, a differential equation of the type dy by dx plus p into y is equal to q, where p and q are exclusively functions of x, is called a first order, first degree linear differential equation. This can be alternatively written as dx by dy plus p1 into x is equal to q1, where p1, q1 are functions of exclusively y. Then this is also a linear differential equation of first order and first degree. So this linear differential equation, students, of first order and first degree has two different forms. This is the first form, and students, this is the second form. dy by dx plus p into y is equal to q, where p and q are exclusively functions of x, or alternatively dx by dy plus p1 into x is equal to q1, where p1 and q1 are exclusively function of y, is called a linear differential equation of first order, students, and first degree. To solve this type of differential equations, we need to have a specific approach, but that theory-based approach I am not going to teach. Let us understand this with the help of an example, students. Easily you will understand with the help of an example, students. So all of you pay attention. We start with exercise 9.5 and do some basic sums today. We start with exercise, students, 9.5 and do some of the basic sums. Now, students, the first sum, exercise 9.5, sum number 1. Each of the following differential equations we have to find GS. Given differential equation is dy by dx plus 2 into y is equal to sin x. Always number the given differential equation as equation 1. Now, students, compare 1 with dy by dx plus p into y is equal to q. P of x is a constant which is 2 and q of x is sin x. This is always step number 1. In the first step, students, we have to compare the given differential equation with the standard form dy by dx plus p into y is equal to q. Always remember, coefficient of dy by dx must be 1. Second step, find integrating factor, which has a formula e raised to integration of p dx, e raised to integration of 2 dx. So this will be e raised to twice x. To solve a LDE, linear differential equation, students, to solve LDE, first step, compare the given differential equation with standard form and write p cube, always coefficient of dy by dx students must be 1. Second step, find out integrating factor. The formula for integrating factor is e raised to integration of p dx, and this is nothing but e raised to 2x. Third step, the solution y into integrating factor will be integral of integrating factor into q dx. This will be done. Generally, we have to multiply the given equation by integrating factor and then solve. What students try to remember the algorithm. In the algorithm, the first step is to compare the given equations and write p cube. Second step is to find integrating factor. Integrating factor is a term which is used to solve a linear differential equation. And the last step, y into integrating factor will be integral of integrating factor into q. So y into e raised to 2x will be integration of e raised to 2x into sin x dx plus c. Here in x as a final constant. All of you know integration of e raised to ax sin bx is e raised to ax upon a square plus b square into a sin bx minus b cos bx plus c. So, students, finally, our general solution will be gs will be y is equal to twice sin x minus cos x upon 5 plus c into e raised to minus 2x. Answers are written in multiple form, so did not worry about the form given in the back. This form of the answer is also 100% valid. So this type of sums are very easy, students. It has the standardized approach, and always we have to compare the given differential equation with, you can say, the standard form and write px and qx in the first step, or alternatively you can say p1y and q1y based on the given differential equation. Okay students, now we are doing sum number 2. The given differential equation is dy by dx plus 3 times y is equal to e raised to minus 2x. Always this will be, students, our result number 1. Students, always this will be our result number 1. Now, concentrate students. If I compare, coefficient of dy by dx is already 1, so p of x will be 3 and q of x will be e raised to minus 2x. P can be a constant, no problem. Step number 2, develop integrating factor, which is e raised to integration p dx. So e raised to integration 3 dx, so it is e raised to 3x. The third step, y into integrating factor will be integral of q into integrating factor dx plus c. So y into e raised to 3x will be integral of e raised to minus 2x into e raised to 3x dx plus c, which will be e raised to x plus c. So this is your general solution, GS. So students, this type of approach or this method is comparatively very easy. We can divide by e raised to 3x throughout or keep it as it is, students. There is no such rule that we should write the answer as given at the back. Answer, students, are written in many different forms. Okay students, now we we are doing sum number 3. Let us do, students, sum number 3. Given differential equation is dy by dx plus 1 by x into y is equal to x square. Okay, students. Now let us do sum number 3. So compare the given differential equation with this. We get dx is equal to 1 by x and qx is equal to x square. So integrating factor will be e raised to p dx, e raised to 1 by x dx, which is equal to e raised to log mod x. So this is written as x. So the next step is y into integrating factor is equal to integral of integrating factor into q dx plus c. So y into x will be integration of x into x square dx, and that is nothing but x cubed by 3 plus c. So students, let us check in what form the answer is written. But answers can be written in multiple form in differential equation. We discuss this and number of times. So this is the sorry students, it is x cube also. I'm sorry. Right students, here x raised to 4 by 4. Sorry students, this is already x cube. So the answer is x raised to 4 by 4 plus c. This is given in the general solution, students. Okay, so all these are, you can say, very easy sums. Okay students, now let us do the next sum number 4. Students, always p and q changes. Depending on that, the integrating factor changes. Okay, now students, we are doing sum number 4. dy by dx plus sec x into y, sec x into y is equal to 10x. And x is in the first quadrant, closed interval 0 to open interval pi by 2. Sorry, because 10 pi by 2 is not defined. Okay, fair. Now students, comparing with the standard form, p of x is equal to sec x, q of x is equal to 10x. So integrating factor will be e raised to integration e dx, e raised to sec x dx. Integration of sec x is log mod sec x plus 10x. So this will be mod sec x plus 10x, but since it is in the first quadrant, we can say that this value will be positive. So here all of you know this, we have used this property. Remember, this is one of the most important property. Y into integrating factor will be equal to q into integrating factor dx plus c. So y into sec x plus 10x is equal to integration of 10x into sec x plus 10x dx plus c. So this is integration of sec x 10x dx plus integration of 10 square x is replaced as sec square x minus 1. And so we get this as sec x plus 10x minus x plus c. This is the general solution, is the GS. Students, don't worry about the form of the answer. Even at the back, again and again, I'm reiterating that the answers in the differential equation are written, students, in a multiple form. So even students, this form of the answer is 100% right. Okay students, now we are doing sum number 5. As such, these questions are very easy students, and do not consider that this is not there in the syllabus, so why we should take pains to go through the questions. This type of mentality students you don't develop, because those who are you can say going to appear for JEE mains, or even if in which case they may keep this type of topics. So please students, do not have the mentality of omitting the things which are not there in the syllabus. Knowledge never goes in vain students. Whatever things you have learned, that particular things never goes in vain. Fifth question, dy by dx. Now I am dividing by cos square. So this will be sec square x into y, and tan x upon cos square x students. So tan x sec square x, I have divided by cos square x. So tan x upon cos square x is nothing but tan x into sec square x students. Now, all of you please pay attention and try to understand this basics. Px is sec square x and qx is nothing but tan x into sec square x. So, integrating factor will be e raised to p dx, e raised to integration sec square x dx, and that will be e raised to tan x. This much I think all of you can very easily understand. Okay students, now what shall we do? Y into integrating factor will be equal to integration of q into integrating factor dx plus, so y into e raised to tan x is equal to e raised to tan x into integrating factors, so it is tan x sec square x dx. So students, pay attention how to integrate this. I am supposing t is equal to tan x, so dt will be sec square x dx, so this will change to e raised to t into t dt plus c. Now integration by parts, I let e stands last, so this will be always v, this will be u. So u as it is, y into e raised to tan x, u as it is, integration of v is e raised to t, derivative of u is 1, integration is e raised to t plus, so finally e raised to t into t minus 1 plus c, so e raised to tan x into tan x minus 1 plus c is the general solution. You can divide by e raised to tan x, and then also you can write the general solution as y is equal to tan x minus 1 plus c into e raised to minus tan x. That is only written at the back. But students, it is not at all necessary to write the general solution in the same form. Students, forgive me, sometimes you can say due consideration my handwriting is automatically decreased inside students. I apologize for that. Yes, please forgive me students for that. My normal tendency is to write with smaller handwriting, so please forgive me for that students. Sometimes in hurry I am writing in smaller handwriting, so please students bear with me. Now students, we are doing sum number 6. Question number 6, students, we are doing. Now, it is x dy by dx. Throughout I am dividing by x always. Coefficient of dy by dx is to be 1. So, dy by dx plus 1 by x into 2y, or 2 by x into y is equal to x square into log x. Okay, students, now concentrate. This has to be, all the sums has a similar approach. So students, here p of x is 2 by x and q of x is x square into log x. So integrating factor will be e raised to integration p dx, e raised to 2 by x dx. So e raised to log mod x square, which is only equal to x square. So y into integrating factor, students, y into, sorry, I forgot to divide by x here, sorry students, I should have written here, x square. So x into dy by dx plus 2 by y is equal to x square by, sorry students, so from the right hand side I have to write only x, sorry, I forgot to divide on the right hand side. So this is equal to integration of q, integrating factor into dx plus c. So this will be y into x square is equal to x cube into log x dx, because q into integrating factor will be, students, x square into x log x, and that will be x cube log x plus c. So now this is algebraic and this is logarithmic. I get L comes first, so this will be u and this will be v. Okay, students. So if I am going to integrate this, integration of v is x raised to 4 upon 4 minus derivative of u is 1 by x, this will be x raised to 4 by 4 into dx plus c. So y into integrating factor will be integration of you can say, sorry, y into x cube will be equal to log x into x raised to 4 by 4 minus 1 by 4 outside x cube dx plus c. So y into x square will be x raised to 4 by 4 into log x minus 1 by 16 x raised to 4 plus c. Dividing throughout by x square, so y is equal to x square by 4 log x minus x square by 16 plus c x raised to minus 2 is the general solution. So here the solutions can be written, again I am telling, in a multiple form. So students, I have divided by x square and correspondingly, students, written the general solution. We can write the solution in many different ways. That we have taken common and simplified. But still, students, our final answer remains the same. So students, here we will divide the lecture into two parts. So in the first part, I am completing up to question number 6. In the second part, students, I will complete another 6 questions to complete the lecture. Okay, thank you, students. Here we conclude the first part of the lecture.